And if we don't get the perfect image without any kind of reflections or artifacts, anything like that, something's wrong.
It's going to take weeks, months, but we did it in one day. It's AI tool, something that you actually are using, and I was super impressive. I never seen this before. So you get cheap, fast, and accurate. And now you are adding one more thing, is AI to the mixture. So I'm super excited actually.
Our AI agent, Bob.
Yeah, I think Bob will be live actually
Bob.
by the time this goes out, so you can talk away at Bob.
Yeah,
Big Bob is going to do.
Big Bob.
Big Bob.
And he is good. We've tested him out a little bit as well, and very efficient. Works very well indeed.
So we have some wonderful guests here today. I'd like you to introduce yourself if you could, team.
Nice, yeah. So my name is Ronan Beadnall. I've been with Zivid for about 3 years now. I'm the sales operations lead, which is a role that's impossible to describe to anyone except middle management commercial people.
Sounds fancy though.
It sounds fancy. It sounds good. I certainly enjoy the LinkedIn tagline, but yeah, that's what I do in Zivid. But I'm also the regional owner for UK and Ireland because if you can't tell by the accent, I am Irish, so it makes sense.
Nice.
All right, I'm Tiago. I'm from Portugal. I work at Zivid as well as Ronan, and I worked there for 3 years now. I am a customer success engineer. My goal is to make our customers be successful. That's in a nutshell. Do some coding and do some commercial aspects. Do some traveling. So it's a dream job.
Perfect. And then we have our very own Rapid Fusion team member, who is the first podcast you've done. So Brian, introduce yourself.
Hello everyone, my name is Brian and I'm the mechatronics engineer here at Rapid Fusion. So my main role is anything to do with software, robotics, and integrating mechanical, electrical to software bits, essentially making 3D printers or robots come alive and coding the brain of them to make things happen.
Perfect. Cool. Awesome. So I think it'd be good for the listeners to understand what Zivid are, what they do, how it was founded, any sort of history you can give us, really.
Yeah, 100%. So we were founded in 2015. So we're a spin-off from Sintef in Norway. We are based in Norway still. Don't think that's going to change anytime soon. We're pretty happy in Oslo. So yeah, founded in 2015 as Shape Crafter. I think we can all agree, the C-suite would agree that the name wasn't great. So we changed to Zivid. Little unknown fact, perhaps, for your viewers and anyone else who knows us out there, that it is Vivid with a Z, because Z for Z value, obviously. So yeah, founded in 2015 and really got going heftily in 2018 with the Zivid 1, then the Zivid 1 Plus, then the Zivid 2, then the Zivid 2 Plus. We have a very specific naming convention. But we are just a pure play kind of camera vendor. Pure play camera sensor vendor. We create a camera or product that outputs the best point cloud money can buy. Or at least that's what our marketing team says.
Nice. So let's dive into a bit of that. So what sort of applications then do you find your cameras being used for? And I guess sort of then bringing that into, I guess, why you're sat with us today and kind of what we're using it for, really.
Yeah, I mean,
I can take this one.
Everything.
So I believe our camera can be used for almost anything that a vision system is required for. We are getting a lot of traction in e-commerce. So everything that's logistics and so on it's a huge market. It's a lot of consumerism going. Everyone wants packages. Everyone wants this grocery things from stores. So it's a lot of these logistic things. And then there is also a huge cut on this manufacturing, which can be from assembly, just picking stuff, or even what you do here, like 3D printing in big scale.
Perfect. I think it'd be good for everyone to understand when you say image capture device, what does that actually mean to the layman?
Yeah.
So from one engineer to another engineer, This is basically, we have a camera that's 2D, and then we have a projector that's 3D. The projector, and then by projecting a pattern and capturing the 2D data from this pattern, we reconstruct a 3D scene. This 3D scene is a bunch of points. Each point is a pixel on the camera. So each pixel will have a XYZ value. That's a representative point in the real world. And that's basically where we stop. And then our customers, like for example, you, will grab this point. Cloud will grab this information, all of these points in space, and you'll be able to manipulate it as whatever you want. In this case, you are putting another layer of polymer on top of it.
Perfect. So I think that sort of brings me nicely on to Brian, really. So Brian, obviously you've been working with the Zivid team for the last couple of days to try to integrate their camera into our ecosystem. So it'd be good to explain kind of what that relationship is like and what we're trying to achieve within our Zeus and Apollo cells.
So the main goal of what we're trying to achieve in the Zeus and Apollo cells really is to enable a scan to mill functionality. So once we've generated or printed a part with our PE320 extruder and Zeus system, now we want to use possibly a CNC tool to finish off that rough edges on a 3D print. And to do that, the main challenge would be to identify where that part is in real time and space, and then try and map an existing milling tool path to coincide with the real point cloud that's generated by the scan, and twist them together so that we can automatically generate correct milling tool paths.
Perfect. And I guess for the user, what that means is that now the system, instead of spending a lot of time manually aligning, which has challenges and also massive risks, because if you've spent a number of hours printing a part and spent a couple $100 or pounds on material, then to misalign and then mill through your print face, this is kind of where the challenge is. So I think the relationship from a very good camera supplier and some good software will allow our users to sort of start to enjoy that one-click workflow of which we're always been working towards. So I think it'd be good to understand, I guess, what sets you guys apart from other camera manufacturers and why. I guess I know why I've chose you, but I guess just speak to why to the viewers, kind of why your camera is enabling our production to do what it's doing.
I suppose I can start on that one. I think with Zivid, we have a kind of ethos where we just, most of our job is just to either put stuff in a box or put stuff on the floor and just image it. And if we don't get the perfect image without any kind of reflections or artifacts, anything like that, something's wrong and we need to make it better. Now, obviously, there's different types of, if you're imaging wood, something like this, your leg, that's easy, right? Mostly because, as Tiago mentioned before, we're a structured light camera. So we're projecting white light. So we rely on the signal to come back to the camera. So obviously, if you're projecting onto something that's kind of this kind of material or, something that's not reflective, you're fine. But as soon as you get into this kind of extra area where something's either incredibly reflective or incredibly unreflective and actually like diffracts the light, for example, like glass or something that's transparent or semi-transparent, then you come into a big issue just within visible light cameras, visible light 3D cameras. What we've done is fix that.
Yes.
So we just made it our mission that, we don't, as I said before, we're a 3D pure play camera. So we don't have any application software. We don't do segmentation. We don't do, what you guys are doing. And we obviously have our own SDK and we have bits and functions with it, but we don't have application software. So our entire company is just focused on getting that picture.
That perfect picture.
Get that picture, So I think that simple ethos has given us the ability to kind of bring it a little ahead. Or we would consider ahead of our competitors. Don't get me wrong, the space is intense. I mean, even we joined 3 years ago. If you start moving in 3D, that's it. You can't stop moving. You gotta.
We completely understand that.
Yeah.
Is the whole sort of environment at the moment is going a million miles per hour.
Yeah.
And
it is.
I guess I think I've probably used it on a few other podcasts and some sort of keynote speeches, but we have an ethos of like innovate or die, essentially.
Yeah, exactly. Because I mean, everyone knows the issues by now, right? Whether it's 3D cameras or a specific application, I mean, the issues are. We're far enough along in the automation cycle that people know what the issues are. It's just about fixing them, right?
Yes.
And then the bigger issues, at least, you know. So yeah, it's very similar. But we're pretty proud of that. We're the first people to be able to image kind of transparent really well. That obviously came from our love of logistics and warehousing. You would be surprised by what people put into a warehouse.
We won't go too deep.
Oh,
into it.
yeah. No,
We'll keep it clean.
No,
for our
yeah,
viewers,
we'll keep it clean for the viewers. But yeah, it's insane. It's absolutely insane. I didn't think people packaged things the way we've seen people package.
A parcel just full of duct tape around. Just that's it. No.
Yeah.
Okay.
Things put in socks. With like a stamp on the edge of it, you know what I mean? And then you have that beside something, you know, like reflective bags and stuff.
Yeah.
But
Nice. So I guess just to boil that down, then it's that image capture bit, and I think probably because you've only really concentrated on that, it means you could really focus in. So you've not got waylaid and bogged down in like lots of software to do random stuff. You've really focused in on the core issue of generally scanning, which is that capture.
Exactly.
So it seems like that has sort of served you guys well.
yeah, it has. And I mean, you got to give props because that is obviously more on the, it's a little bit hardware, but it's a bit more on the, you could argue, software side that the thing. But we have to give big props to the hardware team. We had just won a red dot for the design of the camera. Looks cool.
Amazing.
For all your viewers, if you haven't seen it before, take a look. It's cool.
Yeah, I think we're particularly interested in the form factor because it's very small for what it's achieving.
Let me take this one, actually.
Go for it.
So that's correct. So it's a compact camera. It's 1 kilo. And it was designed to withstand shock, vibration, change on temperature. It's a lot of things taken in consideration when doing the calibration. So it's a huge calibration module with too many variables. And that's also, we found out when we were taking point clouds with the Zivid one, taking point clouds, and after 1 month, the points were 1 centimeter to the right, but nothing changed in real life. So we figured out that something was wrong there. And that's where we found out what's drift. So we don't solve an application, but by focus only on getting the best point cloud, we start to discover things that no one else yet discovered because it was a new technology. It was 6 years ago, 7. So we are trying to, until now, we have changed a lot and we have been digging deep. Now we are trying to solve things that are in noise level. So we're trying to push. We are in the edge of the technology, like you are. We are discovering a new world.
Yeah, it's great. And I think this is what I guess excites us really with our relationship. Like you guys are pushing the limits of the camera, we're pushing the limits of the application. Yeah. And I think when you merge those two things together, you can do some quite cool stuff. So it's been great to see Brian and yourself programming this week. And yeah, I think it'd be good to understand sort of dive into sort of that change of how we programmed here versus kind of what you normally see. So let's talk about AI and programming for a minute.
Yes.
Because I think it's a really interesting topic. It's very topical, and obviously everyone knows that AI and coding are sort of going hand in hand. So for us as a business, like we are achieving great productivity by using AI tools, and I guess we've never really had an external party sort of see kind of our style. So it'd be good to understand what your thoughts are and just share with everyone sort of,
I can. Yeah. For example, We have this SDK, something that is our software, just to take some captures. And if you give me a new laptop, or if I need to put it capturing on your computer, super easy. It takes maybe half hour, and everything should be fine. But now, if you want to integrate our camera actually on your application, now we are talking about starting having tools inside of your application to define settings, to trigger captures, to measure things. That's going to take weeks, most. But we did it in one day. It's AI tool, something that you actually are using, and I was super impressive. I never seen this before, so I was expecting to get here, explain to you our API, how you can take a capture, and then keep in contact with you for a few weeks, making sure you are in the right track and so on. But no, we together make sure that AI was on the good track and things.
Yes, absolutely.
Yeah,
I think it's really, the key thing is how we steer the AI to get what we want, and we just feed AI applications, your API, give it suitable examples of what it is like to integrate Zivid SDK in some other applications. AI takes that as a reference and applies that to our application, our context. And with this blended approach, we've achieved what we could, as per your 1 month of work in a couple of days.
Yeah, 1-2 days. Yes.
Yeah.
Yes.
Yeah, and I guess what that means for us as a business is that we can now concentrate on rich features with not the constraints and burdens of resource.
Yeah.
Because what we couldn't do before these tools were around is we couldn't invest a lot of time and money in coming up with a feature which is kind of like a nice to have. We would concentrate more on utilitarian must-haves. So what that means for the user is you're going to get a richer, deeper experience, and you can only achieve that one-click dream and deleting the user from the activity when everything is integrated so deeply. Because if it's not integrated deeply, you then got to capture an image, and you then got to grab a file, and you got to drop it in here, and then you got to transform it to there, and then that's work. And then every step you put into the UI is another path for the user to fail. And the user is never interested in the journey. They're always interested in the end product. And the end product for them could be a mode tool that's been milled to the correct specifications and then it's been verified by a 3D scanner.
Yeah.
That's what they're interested in. They're not interested in capturing an image and all the details. The details should be hidden and it should just work. And I think that's what the AI tools are being able to empower for us as a business. I think it'd be good to sort of understand from you guys with what you've experienced in this integration. Is there lessons learned that you can take to other integrations?
Oh yes. I'm going to push a lot to actually get this tool on my own. Maybe create a really small application in Zivid. So just try out and then actually understand how it works. And I can recommend to other people, and that is going to ramp up really fast on the speed of what things can be done. Like we have project that takes 2-3 years to actually finish. Maybe now it can take 2 months, 3 months. It's
very possible.
Yeah, I was surprised about the size of your team, I think, actually coming in and the amount that was done and how it was done. And I mean, the amount you can, and not just on the software, but what that kind of lets you do in the long range is actually just getting the product out, right? Because you're not spending all of that time. It was quite shocking, actually, how much.
Yeah, I think there's 2 things on that, isn't there? There's a team that obviously work their arse off, and then there's there's also the being really focused in getting, like, how do we get from A to B in the most logical steps? And I think that's the key to any product successful launch. And don't get me wrong, we are learning on the journey, right? But what we've managed to bring out these last sort of 18 months as a team is unbelievable. But we couldn't do it without the right tools. Like especially like the hardware side is the hardware side, and the AI hasn't quite helped with that yet. I mean, it can give you good examples on on how to design things in a certain way, and like, for example, it's like pulling teeth getting my industrial designer to stop googling things and get off Reddit and use AI to find the perfect widget A that he's trying to find. But yeah, I think that's only going to sort of push into that as well. So, and I guess the use of AI in our applications as well, like we're just about to explore how we can use your point cloud, our SRC file or G code, whatever we're going to use for the milling path, which we're going to try to align. And our next stage as a team is to figure out, okay, how do we actually align that? So we got two choices. We either use pure maths and we got Python, or we have JavaScript or another programming language, or it's like, okay, how about we take a step back and try to upload that data, pure data, into the cloud and into a language model and see whether it can compute and actually do what we need to do on a scalably and repeatably. I'm looking forward to seeing if that's going to work. I'm probably not confident, but a little bit confident. I think
Cautiously optimistic.
Yes, that's probably a good way of putting it. Brian, what's your thoughts?
Yeah, I think that's definitely, it could be a massive breakthrough if we manage to pull this off.
Yeah.
You know, having intelligent, calibrated models specialized in 3D printing / 3D scanning, and being able to actually prompt the user what they should be doing as next step to a task. Let's say our AI agent Bob.
Yeah, I think Bob will be live actually by the time this goes out, so you can talk away, Bob.
Yeah. So
Bob is live right now. Bob is live.
Bob is live.
Bob is live.
Bob is live, and quoting from Martin Jewell, if we added hands and legs to Bob, it might walk away. Yeah. So our AI agent, Bob, essentially, we have this this Bob character embedded into the robot user interface. Yep. So for any user, Bob can listen in to user commands from speech to text, for example. You can tell Bob, okay, now I need to set up, I want to print a mold print for a car bonnet, for example. And find me the file, slice it, and upload it onto the robot. Get the robot ready, set up to print. And Bob might think for a bit, and then he might say, okay, now I understand that you need to print a car bonnet that will take 12 hours. Here's a slice that I've made, and that has been uploaded. The toolpath has been uploaded onto the robot interface. Now, because we're printing in PETG, material is PETG, we now set the temperature zones for our PE320 extruder to the suitable temperatures, setting both extruder and bed temperatures. Very simple. And now waiting to preheat.
So you're saying that the user does not need to care to get the file, to slice it, to define what's the best temperature to put in extruder, depending on the material that's going to be fed in. Doesn't matter how speed it's going to need to be, depending on the size of the part.
So just to add a bit of nuance to that. So essentially, at the moment, what we've managed to achieve is, I guess, that back end. So we've got the slice file. So we have partners such as AI Build and Additive. So especially AI Build, and hence the name, are working really hard to automate that slicing strategy. So us as a business, we're concentrated more on, okay, we've got our slice strategy and it's stored in a central area where it may be, it's been sliced and saved on your computer. And the AI model will obviously have access to that. So what essentially happens at the moment is we upload a file, and then the AI will analyze that file, understands how long it's going to take, and understands what material you've selected, because there'll be a tag in there, and it'll also understand from your context. Like, okay, I want to print a high temperature mode tool. It would then say, okay, based on presets I've already got saved, this is the best material. It'll be a polycarbonate or whatever it may be. So what it's doing is getting your system ready with kind of like as hands off as possible. So I don't know, you're running around the workshop doing lots of things. There's a mobile phone app, so you can just talk to Bob and say, look, it's about to print a mode tool, preheat the system, let me know when it's finished. And what that means is that the system is constantly understanding the real-time data within the control system. So it knows how hot it is, how long it's been heating for, and it uses historical data to understand, okay, last time the user tried to heat up to this temperature, it took this time. So, and that brackets down. So every time you do a heating cycle, it learns from that. So what that means is it knows, like, okay, it's likely that your system will be ready to print in 8 minutes. And the reason why I know that is because last time you've been idling at X amount of degrees for this amount of time, so I'm kind of already preheated. And then to print safely, I've been told these parameters. So it takes all that data, which is what we would normally do just by thinking, right? But the thing is now we don't have to have like dumb timers to say, okay, it's 20 minutes no matter what you do, because that's what the user manual says. Yeah, it's 20 minutes from code, but you've been hot for 2 hours and you're only going up 5 degrees. So why do I need to wait 20 minutes? So we're trying to, like, I guess, make the system more intelligent. And what that does is it streamlines the user input, makes the user be able to print faster and be more efficient and do something else, do something creative or do some other work that's not as menial as sort of standing there and understanding or getting distracted and then putting it on too early and damaging your hardware, right? So that's just like one little thing. And then what the system is aiming to do is like have this like massive, what it's got is a very big knowledge base, which is going to be forever growing because we're going to keep adding to that knowledge the more we use it in-house. And we'll have some customers which are cloud-based, which are happy to contribute, and that'll be also added to the knowledge. But we also have other customers which are IP sensitive, and we have a local model on their computer, and their data stays with them, and that's pretty fine, and we understand that. So with that imported file, now what you're doing is you're exposing your AI to like kind of what good looks like. So the next stage would be to give a print success. So, okay, we printed it and it looks like shit. And it looks like shit because we've scanned it, right? So data is key. So without data, the AI is dumb. So the more we feed it, the better it's going to get. So this is why like having the whole ecosystem of what we're trying to achieve is data heavy. So now the system's going to know what good looks like because we printed it. So it knows what the G code or the SRC code was that it went in, and it knows what temperature it was while it was printing it. It knows where all the motors were while it was printing it because it's capturing all this real data. It knows how fast the extruder was going. It knows how fast the maximum of the extruder was going. It also knows the throughput calibration because we fed it that data as well. It knows the material mechanical properties. It knows the material thermal properties. And then it captures the print after the fact. That is a lot of data. And people cannot compute all that data to find patterns. This is why we're using an AI model. And that's what our AI model, Big Bob, is going to do.
Big Bob.
And
he is good. We tested him out a little bit as well, and very efficient. Works very well indeed. Yeah, I mean, it is kind of, it's crazy how much you're able to do with it. I mean, like I said, we tested it out, and it was just, it was super impressive. Actually, it was. It's something we haven't really seen before, especially, I mean, in any real market. Obviously, it's, automated manufacturing and additive manufacturing is kind of a very specific market we work in, I suppose. But obviously, getting that feedback loop of that is always important. But you guys do it pretty well.
I'm seeing this AI thing as maybe a disruptive way to get inside of the market. To build something, to do something, is going to be cheaper. You're going to be able to take into account more things. it can even change the business model. That actually you no longer need to have 100 developers to do that. You maybe need 2 or 3. So yeah. I actually have a question about how you sell your product. Like you give it a price, you send to a customer that wants to buy it, and that's it. Like how is if you don't mind to share?
Yeah.
How is your
So in terms of the model at the moment, because our AI side of the business is obviously virgin and very, very much new, it will be a free add-on for now. And once we get to a stage where, because to charge someone something, it needs to add value somewhere else, right? I think we had this conversation earlier.
Yeah,
we were
we
like,
did.
okay, why do I need to add a scanner? And we need to add a scanner because it adds this value, and we can charge that back to the customer because it solves a problem. So as soon as Bob starts becoming a necessity, is when we can then charge for Bob's usage, essentially. So at the moment, and also we want users. So we're not going to discourage users with a big price tag, because the more users we have, the better Bob will get. So we need to sort of democratize it as best we can. But obviously there comes to a stage where if it starts to cost us too much as a business, because language models can be expensive, especially really data heavy ones. So obviously that cost will need to be monetized, and obviously we put a lot of development work in. So yeah, that time will come, but at the moment it's a free resource. And yeah, we want feedback really.
And
Yeah.
you are in the right path.
Yeah.
You are in all aspects. This AI thing, also the way that you, the thing that you are doing, producing something that's cheap and fast to print, and then you can go into sub-millimeter precision by subtracting what's in excess. So you get cheap, fast, and accurate. And now you are adding one more thing, is AI to the mixture. So I believe you're actually in the edge of the technology. I foresee great things
Thank
coming
you.
from here. Yeah, I'm super excited actually.
I think we can definitely see the value at least.
Yeah.
It's difficult as well, right? It's kind of trying to get your value out to potential customers can always be a little difficult. I mean, we definitely found it at the start, at least when we started with even just vision in general. It's like people were like, oh well, this is good enough. We can use this. It's something that's maybe cheaper, but really not that accurate. But it's like we've always used this, and then you kind of get that. I mean, you guys are aware of the shit in, shit out. Apologies for the swearing, but that concept, and then you end up with this kind of this loop. Actually, I was talking to someone the other day, prospect coming in, and he was like, he wanted a feature. It was like, do you have this feature? Because this would really be useful, because we use this now. And I was like, oh, you don't need that, because it's an issue with this type of technology you're using. It's not an issue with us. He was like, yeah, I'd really like the feature. And it took me about half an hour to be like, but you don't need it. You simply don't need it, right?
Yeah.
So I think from what we can see, I think the value you guys are providing with everything you're providing is at least obvious to us. But maybe we're so deep into the technology and into the
that's
industry
the hard
that
part,
it's,
isn't it? It's taking. I think we've got the same. Going back to our afternoon meeting, is going from a specification sheet that us as engineers come up with, and then okay, how do you translate that into what's useful for the client? Like, because we're all excited about, I don't know, continuous torque and RPM of motors, but that means nothing to the user, right? So it's then translating, okay, what do all these little things that we put together mean? And what it means essentially is what you said. It's faster, and because it's faster, it's cheaper, and you're getting high quality. So that normal sort of when we set out to build our product line, my mission was always to say, okay, we got a time, quality, cost triangle here. How do we break it? And to break it, we have hybrid manufacturing, and we have a system which can go a lot faster, and we keep the cost down for the user because they're more productive. Simple as that. But it's a simple statement, but to turn that into reality has been some blood, sweat, and tears, Mr.
Definitely.
Brian Cheng.
Yeah.
And I think it'd be good to get your insight, Brian, in sort of how we design our user interface, because that's kind of what you've been working on at the moment, and what that means to our clients. And
Yeah. Should I talk a little bit about how I started and
you go for it.
transformed to how it is now? Yeah, sure. So I think in the beginning, I was tasked by Martin to build a one-pager of this robot UI. I remember that was painful.
Classic CTO behavior.
And that was my first week as well. And so that was a tough week. I had to like cram a lot of new knowledge in my brain to do something that I've never done before. So what really was my experience it was to learn and consolidate new information as fast as possible, and how to get from A to B as fast as possible. That was one of the most trickiest things that I needed to parse in my brain.
What you were like struggling with was that we're no longer at university.
Yeah.
And we need to understand what our blockers are. We need to unblock them.
Yeah.
We don't need to go into the macro detail of why it didn't work.
Yes.
Sometimes we need to know, but sometimes we don't.
Yeah.
And that distinction is something you've been on a journey with.
Yeah, definitely a long 2-year journey. I think I would have said, I can say myself I've improved a little bit, hopefully along the journey. Try to become more effective at prioritizing, what's important and what's not. Anyways, getting back to the UI thing.
Yep.
So on my first week, I was tasked to do a one-pager, and it took, like I said, a week. And that was already with tools like Webflow, and I tried. It was a time vortex, so to speak, trying to connect the user interface to our existing robot system. But now we've completely changed our workflow, essentially, from using what would you call that? Webflow.
I guess it's like a drop and drag sort of, I guess, a plug and play website builder, essentially.
Yeah.
Visual coding, if we want to call it that.
Yeah. So from visual coding to completely coding from an IDE, from a code environment with an AI agent next to it. So moving from this visual coding to this AI agent coding, that really streamlined the process, made everything really much more flexible. We no longer have to rely on constraints provided by,
Templates and stuff.
Existing templates and drag and drop buttons. We can just tell AI to, customize our buttons in a style sheet that we've defined. And we can just tell AI to add different modules and different features and integrate that into our application, like our bead width calibration, thermal camera programs, and integrating Bob into a digital twin, for example. All that.
Yeah, in a matter of sort of weeks and months instead of years, essentially, in a team of 20 people, which enables us as a startup to be more nimble. So I think we're probably running out of time, guys. But it's been a wild 40 minutes.
Yeah.
I think it seems like
What?
40 minutes.
Wow.
I know.
It doesn't feel
Doesn't
it's
feel
been
like 40 minutes.
No,
No.
not at all.
But have you got any closing statements, guys?
No, I mean, it's been, thanks for having us, for one. It was fantastic to be here. It's fantastic to see what you guys are doing. And to have the opportunity to work a little bit with you guys was really nice. See the workflows, see everything. Yeah, been nice.
So 2 things really quickly. First is it's more or less the environment I'm used to. Is when I'm going to visit any customer, normally in these vision systems, it's always people more or less our age or our let's say our between 40s to 20s. So it's always nice to have a connection. It's always people that think more or less alike. And the other thing is, thank you for melting my brain. So when I start to see like, okay, now let's integrate the camera, and Brian just said, sure, AI, Bob, please integrate the camera, and start to write code after code.
It was just hours of Tiago going, "Oh my god!" And Brian's going, "Yeah, yeah,
Yeah.
I had a few mental orgasms as well.
Nice. I think on that absolute
I'm sorry.
bombshell,
sorry.
we'll cut it there. Thank you very much, guys. Brian, thank you for joining us on your first ever Rapid Fusion podcast.
Thank you very much, Martin, for
And
inviting me.
that's it. Cheers, team. Out.
Cheers.
I push it too hard on the fucking mental orgasm.